Hi everyone. So today the topic is about focus on health impacts of pollutants, ambient air, epidemiology and exposure. and exposure. Introduction to air pollution and health. Air pollution is a major environmental determinant of health and a leading contributor to the global burden of disease. Ambient air pollution arises from a complex mixture of particulate matter and gaseous pollutants emitted by traffic, industrial activity, energy production, and natural resources. Rapid urbanization, population growth, and reliance on fossil fuels have intensified human exposure to harmful air pollutions, particularly in low and middle income countries, the adverse effects of observed worldwide. Understanding the health impacts of these pollutants is essential for developing effective public health policies and interventions. Types of ambient air pollutants. Types of First one, particulate matter. A complex mixture of solid and liquids particles are suspended in air and various in size can penetrate deep into the respiratory systems. Its sources is like traffic emissions, industrial combustion, biomass burning, and secondary atmospheric formation. Second one, ground level ozone forms through chemical reactions involving presecure pollutants under lights. Third one, gaseous pollutants. Gaseous pollutants like NOx and SO2 can cause respiratory and cardiovascular issues upon inhalation. And in gaseous pollutions like nitrogen dioxide NO2, it related to traffic, and ozone O3, it is related to the secondary pollutant formed by the photochemical reactions between nitrogen oxides and violet organic compounds in sunlight. Third one, carbon monoxide. It is produced by incomplete combustion, affects oxygen and deliver in the body. Health effects of air pollutants. Like first one, particulate matter. It it affects the respiratory, like airway inflammation, asthma onset and exacerbation, and reduce lung function, chronic obstructive pulmonary disease, and other effects like increased all cause specific mortality, adverse pregnancy outcomes, low birth weight, preterm birth, and metabolic disorders, and type 2 diabetes, and long term exposure is associated with chronic respiratory disease, cardiovascular disease, and increased mortality. Vulnerable populations include children, the elderly, and individuals with pre-existing health conditions. And violet organic compounds like VOCs, it affects the eyes, nose, and throat irritation, headache, and nausea. Some VOCs, example, benzene, benzene are carcinogenic and contribution to the ozone formation. And vulnerable populations like children, other adults, pregnant individuals, people with pre-existing cardiopulmonary disease, and low income and malnutrition. And key public health insights like it affects the health it affects the health occur at low pollutant concentrations, no clear safe threshold, especially for PM2, and reducing air pollution yields rapid and measurable health benefits. Ambient air quality standards and monitoring. Ambient air quality standards are regulatory limits set to protect public health and the environment by controlling concentrations of major air pollutant in outdoor air. These standards are based on largely on epidemiologic, toxicologic, and clinical evidence linking air pollution to adverse health outcomes. And there are some key factors of air quality standards like health based, designed to protect sensitive populations, children, elderly people with chronic disease, pollutant specific separate standards for PM, NO2, O3, SO2, CO, etc. And margin of safety like accounts for scientific uncertainty. And data from monitoring stations inform regulatory actions and public health advices. And commonly regulated ambient air pollutants, often referred to as criteria pollutants, the particulate matter, nitrogen dioxide, ozone, sulfur dioxide, carbon monoxide, lead, and etc. Epidemiology of air pollution related health outcomes. Air pollution epidemiology examines the relationship between pollution level, exposure to ambient air pollutant, and adverse health outcomes. Decades of research across diverse settings have demonstrated that exposure to ambient air pollution is associated with increased mobility and mortality worldwide, making it one of the most important preventable environmental risk factors for disease. Second one, the major pollutants that are studied is particulate matter PM2.5 and PM10, nitrogen dioxide NO2, ozone O3, sulfur dioxide SO2, carbon monoxide CO. Among this, PM2.5 has the strongest and most consistent epidemiologic evidence due to its ability to penetrate deep into the lungs and enter systematic circulation. The third one, exposure response relationship. It associations observed for both short term and long term exposures. Generally linear or near linear relationships, particularly for PM2.5. No clear safe threshold identifier for several pollutants. Health risks observed even at concentrations below current air quality standards. The cohort and case control studies help quantify risk and identity susceptible pollutions. Geographic information systems are used to analyze spatial patterns of exposure and health outcomes. And key health outcomes like mortality, cardiovascular disease, respiratory disease, pregnancy and early life outcomes, other outcomes, stat, other outcomes, and etc. Exposure assessment methods. Exposure assessment is a central component of air pollution epidemiology, as it links ambient pollutant concentrations to individual or population health outcomes. The goal is to estimate how much pollution people are exposed to over relevant time periods. Recognizing that true personal exposure is rarely observed directly, and most epidemiologic studies therefore rely on indirect methods that approximate exposure based on environmental measurements models or proxies, each with distinct strengths and limitations. One of the earliest and most widely used approaches is fixed site fixed site ambient monitoring, where pollutant concentrations measured at regulatory monitoring stations are assigned to populations living within defined area. This method is commonly used in time series and case crossover studies of short-term health effects, where day-to-day changes in pollution are assumed to affect the entire population similarly. While monitoring data are highly accurate and standardized, this approach can introduce exposure misclassification, particularly in areas with large spatial variability or limited monitor coverage. Conclusion and key takeaways. Air pollution remains one of the most significant environmental determinants of population health worldwide. A large and consistent body of epidemiologic evidence demonstrates that exposure to ambient air pollutants, particularly fine particulate matter and traffic related gases, is associated with increased morbidity and mortality across the life course. These adverse health affects multiple organ systems, with especially strong evidence for cardiovascular and respiratory outcomes, and occur even at pollution levels below many existing air quality standards. From a public health perspective, air pollution represents a largely preventable risk factor. Epidemiologic findings have played a critical role in informing air quality standards and demonstrating that reductions in ambient air pollution led to rapid and measurable health benefits. Continued efforts to refine exposure assessments, protect susceptible populations, and implement effective pollution control policies are essential to reducing the global burden of disease attributable to air pollution. Together, these findings underscore the importance of air pollution controls as a core component of environmental health protection and disease prevention strategies. Thank you.